So this is 6 years of distributed GraphQL. So this is actually my first real conference talk since the pandemic, or since before the pandemic, so it has been a while. I'm very happy to be here doing this at the GraphQL Conf, officially organized by the GraphQL Foundation. It's a perfect occasion. My name is Andy. I'm a member of the GraphQL Technical Steering Committee. I'm also the founder and one of the current maintainers of GraphQL Java. And my day-to-day job is at Atlassian. And I gave quite a few talks over the years, but never it was really focused on what we do at Atlassian. So I'm very happy to talk today about our 6 years journey running a distributed GraphQL engine, a distributed GraphQL gateway in production, a little bit what we learned, how we came to do it. But quick disclaimer, all models are wrong, but some are useful. But also, all stories are simplified, but some are useful, interesting, insightful. So for everybody who worked on even remotely similar complex things over years, there's a lot of stuff you need to cut, simplify, make it presentable. Just as a word of warning, nothing is untrue here, but it's a simplified version of 6 years where dozens of people were directly involved and hundreds of people indirectly. So we only have 30 minutes. Okay, let's start at the beginning. Fundamentally, the challenge Atlassian had in 2017-18 was this. We had consumers, or we wanted to have consumers that consumes one GraphQL API. But Atlassian being a multi-product, microservice, or sometimes not so micro, let's call it multi-service architecture, you have this fundamental problem, which I call the distributed GraphQL problem. I hope this naming sticks, and the community is still working on the naming here. But it's really about you have end services, they all have their own GraphQL API. But you want to have one API presented to the consumer, right? Because GraphQL is all about having one endpoint, having the ability to select exactly what you want with less round trips than traditional APIs. So you need to have a way of consolidating all of these different GraphQL APIs and presenting one API to the consumer. So the solution is, the obvious solution, is a GraphQL gateway. Hooray! We're finished, right? Well, writing this box and naming it gateway is kind of the easy part. The hard part was, okay, how does this actually work? The underlying services or subgraphs, both is the same thing, own the GraphQL APIs, and somehow you want to have one API presented to the consumer, right? So this was the starting point of the Atlassian GraphQL Gateway. It started in the beginning of 2018. Of course, we didn't start with being in production, but one of the very first commits were really in the beginning of 2018, so it's over 6.5 years now. It's a kind of unique approach. You will probably not find this anywhere else. Doesn't mean it's good or bad, but it's kind of born out of history and necessity. It's a little bit like a unique approach compared to GraphQL Federation. I will talk about this more. The execution engine, which is called Nadel, which is a German word, Nadel, which is a needle. And if you remember, if you've been around in the GraphQL community at this time, there was talk and there was some early ideas about stitching, schema stitching, like putting different GraphQL schemas in some way programmatically together. And this is where Nadel came from, because in order to stitch, you need a needle. So the German word Nadel is now the name of our engine that actually powers the GraphQL gateway. We offer more, like there's subscription, there's defer, there's persistent queries, there's a little bit like an ecosystem inside Atlassian. We will not talk about all of this today. We have additional stuff on top of all of this: rate limiting, authorization, observability, security. Being a good platform component in a bigger company means you offer common needs or common functionality, and that's exactly what we also do. Okay, to give you a high-level overview, what we do is really, we have two jobs. We, I mean the close team I work with. First, we have a high availability service that really needs to be available 24/7. Even a short outage of this gateway has massive impact on our customer, which can't be tolerated. So we are on call, we have a lot of observability, we're getting alarmed, all of this normal stuff around running a SaaS service, I would say. But then there's the second part of our job, which is schema governance, GraphQL advocacy, tooling, which is a little bit maybe untraditional or unfamiliar. It's because we are a little bit like the GraphQL shepherds inside the company. We own the GraphQL standards across Atlassian, for example. So that's also part of our job. Okay, a little bit what I mentioned before. What does this approach make it unique or different to what most people refer today like federation? It's like, first of all, we predate all of this. I still claim today, and please correct me if I'm wrong, but I still claim that we are the first general distributed GraphQL gateway ever built for general purpose. So we didn't have anything to rely on or like to find a good solution for. We didn't have any inspiration. And the best thing we came up with at this time was, okay, the Supergraph API, so I'm using here GraphQL Federation terminology mostly to make it understandable easily. The Supergraph API for us is maintained separately from the subgraphs. So there is no GraphQL composition which puts all of the subgraphs API together and produces a Supergraph API. The Supergraph API is a separate thing from the subgraphs. It also means the subgraph API is independently of the supergraph. There are no directives, instructions, metadata on the subgraph which tells you how it is exposed via the gateway or so. It's a separate thing. The subgraph lives on its own, doesn't have directives like what we saw on the keynote about lookup or something like this. It doesn't exist. It's all in a separate world which maintains the Supergraph API. But the Supergraph API contains instructions how to map to the subgraph. So it's an inverted approach. You don't start with the subgraphs, with directives, instructions on it. You start with a supergraph which has instructions how to map to the subgraphs. Okay, this was all theoretical. It will become much clearer now, hopefully. This is a simple example. On the left, we have two subgraphs, one issue service, one user service. And these are standard GraphQL schemas, nothing special on it at all. But then on the right, we have the supergraph schema being responsible for the subgraph. So there's a one-to-one relationship here. And as you can see, the supergraph schema for the issues has the directives hydrated, which tells our Nadle, our execution engine, how to transform author ID, which we see on the left side in the subgraph, is transformed as hydrated into a full user object. But the actual schema is just written out. So there's no composition happening. You just declare author of type user, but now you need to tell Nadle or the gateway how to make it happen at execution time. So this is where this directive hydrated comes into play. This is what we call hydration. You transform a primary key, multiple primary keys, something into another object. And yeah, this is this inverted view. You have the Supergraph API, Supergraph schema with instructions how to map at runtime, at execution time to the subgraphs. And then the Supergraph schema for the user service is nearly identical to the subgraph schema for user service, but probably you spotted it. There's a rename directive which changes full name into name. But again, inverted, you look from the supergraph perspective, you just declare name. This is the field that's actually exposed to the consumers. And then you tell Nadle, well, actually, it is renamed from full name. So in the underlying service or subgraph, the field is called full name. And we translate the query and manage everything for you. And to complete this picture, again, on the left side, this is what we just talked about. Now, what does a real overall API look like? This is where a very trivial merging, I would say, happens. The query fields, the root fields are just put together, and all other fields and types are just put in together into one schema. And so from the left side, the schema is merged in a very trivial way on the right, to the right schema, which is the actual schema exposed to the consumer. Okay, I hope that it's clear and was not too confusing. Okay, how do we manage all of this? We have a central schema repository, which is basically just SDL files, the supergraph schemas we just saw with all of these directives on it. And in order to contribute to the overall exposed gateway API, you need to create a pull request in the central schema and say, I want to add this field address to the user. So you open a pull request to this schema, and once it's merged, it's automatically deployed and updated. This is interestingly scaled surprisingly well to more than 1,000 contributors over the years. So you would think this is kind of a joking point, but Git repo scales pretty well. That's like, even if you have hundreds of people continuously contributing to it, if you don't have permanent merge conflicts and you manage the reviewers separately, for example, it scales pretty well, and we have no immediate plans to change that. Okay, one important aspect of all of this is why we did this is we wanted to have an ability to change the subgraph API to a different or like a transformed API when exposing to the supergraph. Because when our gateway project started, there were already APIs in Atlassian in production, used by, for example, a mobile client, which everybody knows can be updated only in certain times, and it takes a long time to fade out users. So we needed an ability to change the subgraph API and adapt it to a slightly different API, which we then actually expose. So the subgraph schema, subgraph services can have different consumers. One that completely bypasses the gateway, which should hopefully only for legacy reasons, but then you also have the gateway itself. So the opportunity or the advantage we have by having a supergraph API separate from the subgraph is that we can quite naturally do quite a few transformations. So if you looked at this example, at the left we have the subgraph, at the right we have the actual exposed supergraph schema. And again, we are just declaring in the supergraph, this is what we want to expose. And then we need to take care of how does this map to the subgraph. So we rename the root field. So legacy orders is actually orders. We rename the order type. So legacy order is actually order. We completely remove the ordered by field. So if you look on the left, we have an ordered by of type ID. This is not present in the right schema. So by just leaving it out, it is removed. That is very natural, very elegant. You just don't declare it, and then it's not available on the overall API, on the gateway API, and that's it. And you can even take it further. We removed the whole interface. So on the right side, we simply didn't declare and didn't use the date entity interface, and that's all. Like you just, as long as you reduce the API and remove something, it's as simple as simply not typing it or not including it in the supergraph API. I hope this again makes a little bit the approach clear, what we have and why we have it. Okay, a few words. The hydrations feature we saw before, which hydrates a primary key, a global ID, to something else, is really the key feature to connect the underlying services. So all of these underlying services, they are separate by, well, conceptually by design, but you want to present a GraphQL API that feels connected, right? That the client can navigate and select, I want for this order, I want to have the user, and for this user the name, and for the name I want to have the whatever. So you want to traverse and have a connected API. Hydration is this key feature that makes it happen. Hydration takes data from one service, transforms it, and presents it as an interconnected API and the overall API. The hydration relies on standard GraphQL fields. That's the point Michael also brought up in the keynote. It's really, we didn't have any other capability to support anything outside of GraphQL. The only requirement we could tell other teams in Atlassian and say, this is what you need to do in order to onboard GraphQL is you need to have a GraphQL API. We could not ask for anything more. So everything what the gateway does, like what Michael called lookups, or what I call here hydrations, relies on standard GraphQL. So if you want to transform or hydrate a user ID into a user object, you need to have a lookup field which transforms a user ID into a full user. This serves us pretty well, by the way, so we are very happy with this choice. And I'm very happy to see that the spec moves also in this direction. One thing is every type and field is owned by exactly one thing, one service. So this is a little bit, I talk to people in the community why we would need shared types and shared fields. And there are reasons to do this, but we simply didn't have the need, and this is where we build it for our own. So our constraint at the moment is we don't have a type that is, we have types that are shared overall, so you can extend a type from a different service, but we can't have two different owners for a type. So one is the primary owner of a type and others can extend it, but it's not like a user type is owned by different underlying services. So it's a little bit like a uniqueness approach or constraint in our design. And honestly, it served us pretty well so far. It didn't came up as a real problem so far. Okay, some lessons. What we learned over the year. The first one is maybe obvious, but how do you say? Hindsight is 20/20. It's always easy looking back and see that was not a great idea. We started with the manual central API review. By having the Supergraph API separate, this was another reason why we made it separate, we wanted to have a central choking point, a control point, a review stage where we could review the API that teams would like to expose via the gateway. And we started by manually reviewing it. Mainly me and another colleague did it. But success came into our way, more people onboarded, more APIs, and we could not scale it up. We could not manually review every field and every type that is exposed via gateway. So central manual reviews are made very easy by our model, but it didn't scale. So it provided better APIs maybe overall, but it came with such a high cost that now we changed to self-responsibility model, where every subgraph is responsible ultimately for their API with some constraints which we set. So we define certain rules, schemas, some of them are enforced, and inside these rules, the underlying teams can do what they want. Okay, so that was a fun one. That's just on me. We actually started with the custom DSL. So this is an example, a real example from a first version of Nadel, where we extended the GraphQL schema definition language with custom keywords like hydrated. As you can see, I invented this arrow and then hydrated from users, blah, blah, blah. So you were able to specify in your Supergraph schema with this custom DSL how you want to hydrate, for example, things, or how you want to rename. Well, today it looks like this. Today we are using standard directives. And the reason is I still believe a DSL would be more readable overall, especially as the instructions get more complex. But the truth is, maintaining an ecosystem of editors, tooling, linting around the custom DSL is a very, very high cost. Like, again, with greater success came greater adoption, more people wanted to use it. They used different editors, not just IntelliJ, also Visual Studio Code, maybe even something else. They wanted to use custom parsers. There's a lot of stuff that directives, because they are built into the GraphQL language, they are just supported out of the box. And running a custom DSL on it is simply such a big expense that we could not afford it. So we opted for a decent, or maybe sometimes or even good experience is more worse than a great experience with great effort. So yeah, custom DSL is not more. Okay, adoption. So this is maybe one of the most interesting parts. There's a cost to this model. So having a supergraph API separated from the subgraph gives you great flexibility. You can do transformations. You have a central review point. You have a very explicit stage where you can manage things. But if you have teams that start with this distributed first mindset, and with that I mean that they start contributing to the gateway from day one. So they really want to get on board the gateway and expose their API through the gateway. Then there's a cost to having like a separate central schema and having a separation between supergraph and subgraph. And you can minimize those costs with tooling, automated pull requests to the central schema, and so on. But somebody has to pay this cost somewhere. So a federation approach where you have the directives built into the subgraphs is overall, I believe, less costly for these distributed first teams than our approach. Also, the separation of supergraph and subgraph can cause what we call a drift. So a subgraph can evolve independently from the supergraph, and that's all fine, and that's by design. But of course, it should not evolve in an incompatible way. And this is where you get problems, right? Like if you remove a field in the subgraph, you still have the supergraph schema declare this field, and the gateway tries to query this field, then you have errors and problems and incidents. So this separation, again, needs to be maintained. And again, we have tooling. It's not a huge problem, honestly. It's not something that makes it in any way a headache, a real one. But again, there's some cost to it that we manage, and it's fine, but worth mentioning. Okay, moving on to a little bit broader topics, not so specific to the gateway. In general, so I'm doing now GraphQL since it came out open source, so next year it will be 10 years. I gave a lot of talks to a lot of different audiences. I stopped counting a long time ago about GraphQL, and I can really say GraphQL is easy to learn. I will maintain this. If you have a programming background, if you know how to program, GraphQL itself is quite straightforward. You have 6 different kinds of types. You have nullability. All of this is quite familiar with all people. And even the finer parts of the execution, people get it once you explain it a little bit to them. It's not a real problem. Never it came up like a hard blocker. But this is what it gets interesting. The way how you design a schema, and I could give a whole talk just about this is actually the hard part we learned. So GraphQL itself is, if you look into the spec, first page, second page, somewhere around this, there's a sentence about GraphQL is unapologetic client-driven. So this is, by design, in the roots of GraphQL, it's a front-end serving technology. So you design the GraphQL schema for the needs of the front end, for the use case of this front end. And this is in conflict often with the back-end driven schema approach, which has a more holistic view where you try to keep, for example, fields clean and not repeated. While when you have hundreds of components on the client side and you want to have the best experience for these components, you end up often with field duplication or similar types, or you need to deprecate the old one, introduce a new one while the old one is still there. So this leaves you in a very simplified way with a messier schema than compared to a clean, holistic, backend-driven approach, where you try to clean up one concept represented by one type. No, the front-end had 100 components with the types represented in 15 different variations, because you have combo boxes, checkboxes, list fields, you have different views on things. So there's a conflict in this, and this actually takes much longer to learn and to digest, especially for backend-driven design or backend teams. They have often the urge to keep it clean, dry, don't repeat yourself, and these are in conflict with the real client-driven schema approach of GraphQL. Okay, a few thoughts about distributed GraphQL future. We heard actually a lot already in the keynote. First of all, AGG is a consequence of a unique situation. We were very early. We had the knowledge, like me and my co-maintainer of GraphQL Java worked at Atlassian at this time. So we were able to build the solution because we had the very specific knowledge to pull it off. It's not something that kind of was planned or envisioned or something. It was a unique situation. We had a problem, and we had a solution or the abilities to build a solution to it. I would say, in general, distributed GraphQL is hard. You probably should not try to build something like this on your own. It's like you should look into buying it. That's my general approach. And I'm not alone. We see quite actively a vendor landscape is evolving from Apollo as the earliest, right? But we have Chili Cream with Michael, we have the Guild, we have Wundergraph, we have others here. So we have an actively evolving vendor landscape, which is kind of testament to that's a hard problem that people want to get solved. And fundamentally, I agree. My experience over the last 6 years, we invested a lot of deep knowledge, time, and effort to make this work, and it's probably not your core business to do this. I'm very happy that the distributed GraphQL standard is on its way. Awesome work by the involved companies. We saw that in keynote. I will not repeat much more. It's great that they all come together. But what is specified is somewhat different to what you saw today. The supergraph versus subgraph separation with the instructions in the supergraph level and having this separated is different from the federation or from the specification they work on. So what we do is fundamentally compatible. You can reach the same outcomes, but technically it's not the same thing. Yeah, thank you very much. Do we have time for questions? Oh, I think so. Let's do questions. Okay, let me repeat. The question is about governance and how we achieve some sort of governance when we can do it, when we can't do it manually, right? So the answer is not too surprising, honestly. We have linting in place. So you, for example, when you declare a connection, like something ends with the word connection, we enforce the relay spec one-to-one. You're not allowed to your pull request is not successfully built and mergeable until you do it. We have naming patterns. We have, outside of this, standards written down, which is more design guidelines. Yeah, so these are the rough guardrails we have in place. Honestly, it's not too painful. Like it's not rocket science to build this linting, and it's quite custom in some aspect again, but it's not the hardest part. Yeah, so, but you have to do it in order to have some consistency at the scale. Yeah. Yeah.
In your adoption lessons learned, you mentioned about getting folks to the point of thinking client-oriented in GraphQL. What are some of the ways in which you got to that evolution yourselves?
The question was, how do we got to this client-driven approach? Well, it's really experience that was again driven by client-side developers. When they develop their front end, especially with Relay, and you have a very component-oriented approach, they want to have a GraphQL API that fits their needs. And when you look at this and then you look at what the backend maybe wants to provide, you see the friction and you see how it doesn't fit naturally, and then you need to start discussing and maybe say, backend, no, it's okay to have a second field that looks similar, but the frontend needs it and they need it for this use case, so please add it. So it's kind of being in the middle of both sides made us realize this or learn about it. Yeah. Yeah, exactly. Well, so ultimately, it's really shared conceptually, but the backend is the one that needs to implement it and run it and operate it technically. So they often have a more naturally pull to own it. But if it's really client-side specific, you need to cooperate. You need to cooperate. That's a simple and hard answer at the same time. Okay. Yeah. No, definitely. So the question was if we saw more benefits around having a separation between subgraph and subgraph, not just for mobile. Yeah. No, we saw it. It's like, so I mentioned a mobile client, but sometimes also web clients have a longer time to change. So even for different consumer, we had sometimes the need to transform the API and keep legacy APIs in place, if that makes sense. Okay, let's do one more. Yeah.
So, was the answer to solving for the drift linting?
Yes. What is the answer to solving the drift?
You said that the notion of subgraphs evolving independently.
Yes.
Supergraphs could cause a drift.
Yes.
Was the way to identify the drift like constant linting?
Yeah, like the way how we prevented the schema drift I mentioned between supergraph and subgraph, again, is not too much rocket science. Is we are introspecting the underlying service and finding out what is the actual real API the subgraph provides, and then we are comparing it with the API that the supergraph expects to work. And if there's an incompatible or breaking change, we raise alarms or handle it. Yeah, it's introspection based.
How do you handle that breaking change? Like there's a need for it, we want to push forward with this breaking change.
Well, the subgraph needs to be changed again to make it compatible. Like so that like if the supergraph demands it and it's in production, the subgraph can't just remove a field. It's an incident, and the subgraph needs to not break the supergraph.
Have you ever come across any use cases where you needed to introduce this breaking change?
I don't think there was ever a very hard need to introduce a breaking change. It's more like at some point, if there's really no usage, breaking changes is acceptable. But much more often, the breaking changes are premature and driven by a need to clean something up that maybe you're not allowed yet to clean up. So yeah. Okay, thank you very much.